Hello all, I'm Scott Moore, Senior Technical Account Manager supporting HPE at Ingram Micro. And in this session, we're going to go over the basics of storage technology. So for our agenda, first we're going to talk about primary storage and some of the storage technologies behind that. We'll talk about hard drives, SAS versus SATA. We'll talk about flash storage. We'll also talk about direct attached storage or DAS. From there, we'll go on and talk about shared storage options. We'll talk about network attached storage or NAS, storage area networks or SANs, and we'll talk about the two most popular types of SANs, fiber channel and iSCSI. Then we'll talk a little bit about secondary or archival storage, and we'll go over tape drives, LTO and Ultrium technology, autoloaders, libraries, and virtual tape. And then we'll wrap up by talking about a couple terms that you'll hear of a lot in reference to storage: deduplication, thin provisioning, replication, and snapshots. So in the world of storage technology, the common drive interfaces are SATA and SAS. The difference between the two, SATA tends to be slower and less resilient, and it's typically found in client systems or for archiving. Although I say it's typically used in client systems, you will find it in the data center world quite a bit, usually as a low-cost alternative for storage. SAS is a faster interface. It is 24/7 compatible, and it's used in most enterprise class systems, where SATA typically has a use cycle of 8 hours with periods of being on and off, used for a max of 8 hours before given a downtime period. SAS is meant to rerun 24/7. That's why you see it more in the data center world, where servers are going to be running pretty much nonstop around the clock. Other primary storage types, we have hard drives that use those interfaces. Hard drives are the old technology that's been around for a while. You have platters covered with magnetic material on a spindle. They tend to be slow and prone to mechanical failure. The more recent standard is flash or solid state storage, in which we have transistors on a chip. Much faster than hard drives, and it's all electronic, so you don't really have as high a likelihood of mechanical failure as you would with hard drives. So there are many different types of flash storage out there. There are the USB thumb drives and the SD cards that you usually find on client systems like desktops, notebooks, cameras, cell phones, things like that. It's that same transistor-based flash technology that you also find in SSD drives, which are just the same form factor as hard drives, making it easy to put SSDs in systems where we previously had hard drives. There's also a storage technology called M.2. M.2 is flash storage in the shape of a stick of chewing gum, or if you want to think about what a memory DIMM looks like, but instead of having the connectors on the long edge, the connectors on one of the short edges. It's essentially an SSD drive in just a different shape. There's also one of the recent additions is NVMe, Non-Volatile Memory Express. Non-Volatile Memory Express comes in different form factors. You can get it so it looks like a regular drive. You can also get it in M.2. You can get it on PCIe cards. And this connects directly to the system bus, your PCIe system bus, for better performance, where typically SAS SATA drives have to connect through a hard drive controller. Your USB drives are connecting through a USB controller interface. NVMe connects directly to the system bus and gives you much better performance when it can, actually at the highest level of performance you can get for storage devices, for traditional storage devices. In addition, there's also something called persistent memory or storage class memory, SCM. Same form factor as RAM, and it goes into the same slots as your memory goes. And this is really meant to be a high speed, near memory speed storage, but the advantage of it is it can store data. Typically, when you turn your system off, you lose everything in memory. With persistent memory, you can actually store data there. It's advantageous for things like databases, which run much better when you can copy the entire database into memory. Persistent memory would be great for something like that. Intel Optane is probably one of the best known examples of persistent memory. For direct attached storage, or DAS. Direct attached storage is simply storage that is plugged directly into a single computer. Think hard drives, optical drives like CDs or DVDs, USB flash drives, SD cards, M.2 or thumb drives. Those are all plugged directly into or directly attached to a single computer. You can share that data through your operating system, or you can copy it across the network or email files out, but it's still owned by a single computer. It's directly attached to a single computer. External examples of direct attached storage, things like USB keys, thumb drives, portable hard drives. On the enterprise world, there are external enclosures, sometimes referred to as JBODs, just a bunch of disks, which are drive shelves that can hold additional drives that are tied back to one particular server that owns all of that storage. A lot of times those are connected to RAID controllers. So instead of just being just a bunch of disks, you can perform RAID on the drives on those external storage systems as well. They do tend to be less expensive than shared storage. Because if you're getting a DAS device, you're connecting it to a single server, you don't need to have the sharing mechanisms that are built into shared storage devices like NAS or SAN. It's pretty much just direct attached technology. So you get to save a little bit. It tends to be less expensive if you're adding storage that can only attach to a single server, as opposed to storage that can add to multiple servers. And as I said before, it is single owner storage. Anything in that direct attached storage system or on those direct attached internal devices, they are attached and owned, managed by a single server. Moving on to shared storage, kind of the entry-level version of shared storage is a NAS, network attached storage. NAS devices have multiple owners or multiple folks who can access it. Multiple clients might be a better way to put it. I can put data out on NAS device. It's really just one or more drives in some sort of external case with an Ethernet port for connectivity. I can put data out there, and anyone else who's attached to the same network as that NAS device can access the files on there. It has typically a built-in operating system, so it functions kind of like a file server. And it's a good alternative for a file server for a small work group, small office, home office environment, rather than buy a full server and an operating system and client access licenses. That's all you really need to do is share some files. A network attached storage solution might be a perfect alternative, and you can save on those software and client access license costs. NAS devices provide something called file level access as opposed to block level access, which you have with SANs, and we'll talk about that in a little bit. But file level access is for people who need to access data a file at a time. Think of it as office files. If I'm doing PowerPoints, Word files, Excel spreadsheets, when I want to access that file, I want to load that entire file into my program. That's file level access. There are situations where you might not want to access data on a file level, and that's typically what we refer to as block level access. An example of that would be if you're looking up an invoice or a customer number or a part number, something like that. You don't want to open a file that has all the invoices ever billed, all the customers you've ever dealt with, all the part numbers that your manufacturer carries. You want to put in a part number, some sort of key or a customer number, and be able to pull up just the specific records you care about, kind of like a database. That's block level access as opposed to file level access. I want to pull in part of the data stored in a file, but not the entire file. When you have applications where you want to do that, NAS is not necessarily the best choice, but for shared storage that needs block level access, we have storage area networks. Same three letters, just in a different order. SANs. SANs are shared storage that have multiple owners. The components for SAN, you have server adapters, which are referred to as host bus adapters or HBAs for fiber channel, or just regular network interface cards or NICs for iSCSI. You have cabling, and it's either fiberglass or copper, depending on what you're implementing. And you have switches. And with the switches, you may have SFPs or QSFPs as adapters for cables if you're doing something over fiber optics. And then finally, you have the SAN storage system, which holds all the drives which contain the data that you're going to make available to those multiple owners. The two main types of storage area networks I mentioned before, we have fiber channel. Right now, the common standards for fiber channel are 16 gig or 32 gig, 32 gig being probably the most prevalent right now and 64 gig on the horizon. It is the oldest SAN standard currently in use, and it uses glass components. So the cables are all fiberglass based as opposed to copper wire based. An alternative that came out a little bit later was iSCSI. iSCSI is 1 or 10 gig. Mostly now it's 10 gig. There is some 25 gig out there as well. And it uses pretty much standard Ethernet components. So you don't need special fiber channel switches or HBAs. You can use regular NICs. You can use regular Ethernet switches. And as I mentioned before, storage area networks are good at that block level access. So when I need to share databases or huge collections of anything that's keyed, part number databases, customer databases, invoices, things like that. That's when you're going to use a SAN over a NAS device. So what does a SAN kind of look like? Well, my servers are going to attach to it, and I can have any number of servers. In this case, I just have 2. Each of those servers is going to have some sort of device that allows them to connect to the storage area network. So I mentioned before, if it's iSCSI, they're probably going to be extra NICs. In the case of fiber channel, they're going to be HBAs, which I've shown here. The fiber channel storage system in this case also has, or I should say every device on the SAN essentially has a cable coming off it, whether it's a storage device, whether it's the server HBAs. There's a cable for each device that the other end of which connects back to our fiber channel SAN switch. In the case of fiber channel, you can see I have 3 little adapters there at the end of each cable. Those are going to be what used to be called GBICs back in the days when fiber channel was only 1 gig. Now they're SFPs or SFP pluses or QSFPs. XFPs is an older standard as well. And those adapters essentially convert the light impulses coming across the cable to electrical impulses that the switch can understand. So a total list of our components there. We talked about the servers, the storage system, the switches, and all those are connected together with HBAs and cables and adapters back in the servers. So between fiber channel and iSCSI, let's do kind of a really rough abstract kind of comparison between the two. If I want to do a basic fiber channel SAN, let's say the layout that we have here, just 2 servers. I'm going to need 2 HBAs using really rough numbers, maybe $500 a piece for those HBAs. My fiber channel storage system is about $7,000. My fiber channel switch can also be about $7,000. I'm going to need 3 glass cables, which would be about $100 each, and 3 of those SFP plus adapters, which can be about $500 each. So my entry level cost in a fiber channel SAN is going to be $16,800, not counting the drives that I need to put in my storage system that actually hold my data. But the basic infrastructure for that SAN is going to be about $17,000, just as a rough estimate. What if I want to do the same thing via iSCSI? Well, with iSCSI, I don't need these special HBAs. I can use regular NICs. Maybe the NICs are only $100 each. An iSCSI storage system, probably roughly the same cost as a fiber channel storage system. So that might be about $7,000. An Ethernet switch, though, I can get a low-end Ethernet switch for $500 or less. My cables are going to be regular copper wire cables, $5 a piece, which is going to be a lot less expensive than the fiberglass cables used for fiber channel. And the SFPs, those little adapters that converted light signals to electrical signals, well, since I'm using regular copper-based Ethernet and I'm not doing anything involving light signals, I don't need those SFPs at all. So there's some savings on the iSCSI side. So my entry-level iSCSI SAN infrastructure comes out to be just under $8,000, roughly half or a little bit less than half of what it costs to deploy a similar fiber channel SAN. So why would I ever go with fiber channel over iSCSI? Well, look at the top row in dark blue, and I've listed the speeds that I was kind of working with. Fiber channel is going to give you 16 gig on the low end, and iSCSI is going to be 1 gig. So there's a huge difference in performance and bandwidth between the two solutions, and that's really what separates iSCSI and fiber channel in a lot of cases. The less expensive iSCSI solutions will tend to be slower. The faster solutions tend to be fiber channel and more expensive. If performance and speed is critical, you probably want fiber channel. If speed and performance is not necessarily critical, you're not doing anything that's going to tax the bandwidth of your storage system, you might be able to save some money and go with an iSCSI solution, and that'll work just fine. Switching over from storage area networks and primary storage, let's talk a little bit about tape technology. People say all the time that tape is dead, and I've heard that for 25 years, and yet it's still around and new products are coming out. The beauty of tape is I can make a copy of my data onto something small and portable I can take off-site, stick in a safety deposit box, bring it home, whatever. In the case of emergency, I have something I can restore my entire business from that was taken off-site. So if I lose my entire location, my office building or whatever, I can restore my business, the computer portion of my business, from this portable cartridge I took off-site and have somewhere else. There used to be many different tape standards, and there still are, but most of them have kind of dwindled to small groups using them. The most common nowadays is something called linear tape open, or LTO, also known as Ultrium. And every time there's a new Ultrium standard, they increase the capacity, and it used to be they increased the speed, although I think the speed has pretty much stayed roughly the same over the past, or not very much over the past couple generations. But Ultrium 9 is the current standard for LTO tape. The older LTO 8 and LTO 7 are still around. And what I have listed here is the native capacity for each tape for Ultrium 7, Ultrium 8, and Ultrium 9, 6 terabytes, 12 terabytes, 18 terabytes. What I have listed in parentheses after it is the compressed capacity, or the approximate compressed capacity. And what I mean by that is there is a standard lie in the tape industry. All tape manufacturers will take the native capacity of their Ultrium tape and multiply it by 2.5. and say, this is the approximate capacity you will get if you're using compression. Well, compression varies quite a bit depending on the type of data you're trying to compress, the size of the files you have, things like that. So there is no guarantee that you're going to get a 2.5 compression rate if your software, if your backup software even allows you to compress the data. But it's become so prevalent in the industry, you will only see Ultrium 9 tapes advertised as 45 terabytes and Ultrium 8 tapes advertised as 30 terabytes. And you may think, really? Everybody does that? Yes, everybody does it. Because if one person was to sell an Ultrium 9 tape or a tape drive and call it 18 terabytes, no one would buy it. Because everyone would say, why would I buy this one for 18 terabytes when this other manufacturer has one that says it's 45 terabytes and costs the same amount of money? It's the same drive. Nobody uses the native capacity of the tape in advertising their LTO drives. So that's something you need to take into account when planning a backup. If I have 30 terabytes to back up on Ultrium 9, even though they will advertise it as a 45 terabyte tape, I might want to make sure I have at least 2 tapes on hand, because natively I can only fit 18 terabytes onto a single Ultrium 9 tape. And as I mentioned, usually somewhere in small print on the Ultrium products, they will list that Ultrium 9 is 45 terabytes, but in small print, it'll say something like 18 terabytes native capacity, 45 terabytes with 2.5 to 1 compression rate, or something like that. If you search the specifications on the Ultrium drive enough, you'll find those notes. Tape devices. You can get tape drives in several different formats, and I'll quickly go over kind of what the benefits and the drawbacks are to each type and why you would choose one sort of tape drive over another. So a standard tape drive holds one tape and has one drive mechanism, one read-write head that reads that tape. If you have a small amount of data to back up, that may be perfect. If you run your backups at night, let's say, and in the middle of the night you run out of tape, your backup will sit there waiting for you to swap tapes, stick in a blank tape, and hit enter on your software to continue to do the rest of the backup. If you're doing this in a business, when you come in first thing in the morning and you have to swap tapes and then the backup continues, it's pulling data from across the network to back up. So your users on your network, when they first come in the morning, they're going to say that the network seems very slow because that backup didn't complete last night and it's still pulling data across the network to back it up. The solution to that would be an autoloader. An autoloader still has a single drive, so a single read-write mechanism, but it holds multiple tapes. So in the middle of the night when you fill up that first tape, a robotic mechanism within the autoloader unloads that first tape, sticks in the second blank tape, and continues the backup. And if you need more than 2 tapes, it will continue to swap tapes all night up to the maximum cartridge capacity of the autoloader. That's great. You come in the morning, if your backup took 7 tapes, it says, hey, your backup is done. Here's all 7 tapes. The problem there is perhaps my autoloader has enough capacity to back up everything I need to back up. It's just that it takes ridiculously long to back up all that data. Let's say I usually kick off my backups at 5 p.m. If I have a ton of stuff to back up, even if the capacity can be held by the number of tapes in my autoloader, if it takes me 26 hours to back up, I'm going to have a problem if I'm kicking off a new backup every 24 hours and it takes me 26 hours to back up. The solution there is a library. Like an autoloader, a library will hold a large number of tapes, but it also holds multiple drives. So those drives can work simultaneously in tandem. So if I have something that takes me 24 hours to back up, if I have a library with 2 drives, it'll only take me 12 hours to back up. If I have 4 drives, it'll take me 6 hours to back up. If I have 8 drives, it'll take me 3 hours to back up. Depending on the number of drives you have in that library, you quickly reduce the overall time it's going to take to complete a backup. There are also things called virtual tape, or disk to disk, or D to D, sometimes they're referred to. And this is using hard drive storage as a backup. And virtual tape devices typically emulate some sort of tape drive. So in your backup software, you may refer to it as a tape drive, and it kind of simulates a tape, which is why they call it virtual tape. A lot of times too, you can connect an actual tape drive to a virtual tape device and offload what's on the disk to disk of the virtual tape device to a tape. So you still have the ability to take a tape cartridge off site in case of disaster recovery. But where virtual tape is really good, usually when we're thinking about restoring from backups, it's not because of a catastrophic failure. It's because somebody accidentally deleted something they needed. And in that case, it's kind of a pain to go to the bank, go to the safety deposit box, take out a tape cartridge, load up the tape cartridge, and restore one file that some guy in IT accidentally deleted. With a virtual tape, you have that box of hard drives on location. So it's very easy to say, oh, this was a deleted file, no problem. I can go over to our virtual tape device. I can find that file from yesterday's backup and restore it to you. So although tape is great to restore in case of a catastrophe, virtual tape is great to restore in case of an accident. accidentally delete something, you want the older version of something back. If you have a virtual tape in-house, it's easy to pull data off of that. Virtual tape is commonly connected via SAN. It's usually a fiber channel or an iSCSI device, and they frequently support deduplication too. So if I have 50 terabytes to back up from multiple user directories, I might find that with the redundancy in emails and some of the similar emails being sent out across teams, maybe it only takes me 30 terabytes instead of 50 terabytes to back up, because deduplication will eliminate that redundant data from my data set. And also it's great for archiving and quick local restores, as I mentioned before, of recently deleted data. I'm going to switch and talk a little bit about some terms used in storage. And I just mentioned deduplication, so we'll start there. Deduplication is commonly found on many of the high-end storage products as well as virtual tape backup devices. It is the ability to eliminate redundant data or duplicate data from a device. It's also known as single instance storage, which is a term that Microsoft used to use a lot. Store once or catalyst are the phrases used by Hewlett Packard Enterprise, and sometimes people just refer to it as dedupe. With deduplication, duplicate data is eliminated and replaced by a set of pointers back to the original occurrence of the data on the storage device in order to save space. So if you think of you get the email that's sent out to all associates at your workplace about a company event coming up next week. When the user accounts are backed up, do we really need to back up that email 500 times for each person who received it? Probably not. So the first time it's encountered, the backup software will back up that email. For the next 499 times, it doesn't back up the email, but simply says, this person also has a copy of the data held by that first user. And it just points back to the one time, the first time it was backed up. Using that, you can save a lot of space on your backup device or your archival device by using deduplication. Thin provisioning. Thin provisioning is commonly found on high-end NAS or SAN devices, is the ability to dedicate just enough space to hold the files a volume will contain with no free space. A storage volume can then grow dynamically when needed up to the amount of space that was originally requested. So for example, if I have a 20 terabyte volume and I have 3 departments each saying they need an additional 10 terabytes of storage, well, there's no way I'm going to get 30 terabytes out of a 20 terabyte storage system traditionally. What thin provisioning will let me do is I can create 3 separate volumes, say that I want each one to max out at 10 terabytes, but instead of allocating the entire 10 terabytes of storage, it allocates only enough space to hold the files that are put there. And as more files get put there, the size of that volume grows until it hits a max of 10 terabytes. So for those 3 departments that each requested 10 terabytes of storage, if each of them only has 5 terabytes of files, I can create 3 10 terabyte thin provisioned volumes, store 5 terabytes from each of those 3 departments, and you know what? Each one of them has all the space they need, and there's still 5 terabytes left on that storage system. As those volumes grow, I may eventually need to buy storage down the road, but initially I can give them all the storage they need to hold the data that they have. Unused space or unprovisioned space on those volumes can usually be assigned to other volumes as well. So in that situation, if I do 3 thin partitioned 10 terabyte volumes, and I'm only using 15 terabytes of the whole 20 terabytes physically available, I can allocate that extra 5 terabyte space to another volume if I wish to in the meantime. Replication. Replication is a technology commonly used on storage area networks. Replication is keeping an additional full copy of a volume for backup purposes or failover purposes. It's generally scheduled, and once it's scheduled, it's ongoing once it's set up. There are two main types of replication. One is synchronous. Synchronous means it's constantly updated. Typically, you do this over short distances. So if I have a data center in one building on campus and a backup data center in the second building on my college campus or my medical campus, that's a relatively short distance. I can use synchronous replication. So roughly speaking, the instant I lose one data center, the backup data center, will have pretty much an up-to-date copy of what was in the primary data center when it went down. The other type of replication is asynchronous. Asynchronous as in not synchronous. It's updated at regular intervals. And so it's not always fully in sync with your original data set. So why would I do asynchronous? I do asynchronous when I have to transfer data over a long distance. So if I have a data center in California and I want my backup data center in New York, I would do asynchronous replication. So maybe I set it so once every hour or once every half hour, all the changes from the previous time period have been collected, and I send those changes to my other data center. In that example, if I lose a data center, at worst, I'm a half hour or an hour behind, and I've lost a half hour or an hour's data as opposed to losing all my data because I did asynchronous. And the reason we choose to do asynchronous over long distances is just because you can't have that constant data stream that you do with synchronous replication because it takes so long to propagate that data over such a long distance. So here's a diagram that kind of goes along with replication. I can have, in this case, I have 3 locations. I have one in California, one in Virginia, and one in London. My data center, my backup data center, A and B in Santa Clara, I can do synchronous replication between those because they're located on the same campus or in the same city, relatively short distance. So I can keep those 2 in sync. If I lose A, B has a full copy of my data. If I lose B, A has a full copy of my data. And the same thing is true in Sterling, Virginia. Those A and B storage systems are doing synchronous replication, so they are pretty much in sync. If one of them goes down, the other one has pretty much a complete collection of data. However, in London, I have a single data center. I don't have a backup on site. If I lose London, I don't have a backup data center in London I can go to. So from there, I'm going to choose to do asynchronous replication. And maybe I will do asynchronous replication to Sterling and to Santa Clara. In either of those cases, when London goes down, Sterling and Santa Clara both have a near complete copy of the data that was in London. What they will be missing is whatever the time difference is for the scheduled asynchronous replication. If I'm doing asynchronous replication every hour, I might lose up to an hour's worth of data. If I'm doing it every day, I may have lost up to a day's worth of data. But the vast majority of my data is still available at either of those 2 sites I've been asynchronous replicating to. Snapshots. Snapshots is a technology that's commonly found on SANs. Snapshots are also known as clones, and they are virtual copies of a volume that allow an administrator to roll back to a particular point in time. They're usually either created by an administrator or they can be scheduled as well. And there's 2 different ways I'm doing them here. There's 2 diagrams. There's one called copy on write. There's one method called redirect on write. Basically, what you do is when I decide I want a snapshot, I have my current state of data. From that point on, any changes that would be made, I don't change the original data. I keep a copy of the changes. In a copy on write, I am changing my original data, but I'm taking the data that was originally there, the original copy of it, and storing that separately. So in this case, I made a modification to block C. Before I overwrote C, I made a copy of the C block of its original data. On a redirect on write, I leave my original data alone. And if I make a change to C, I create a whole new block, which is a copy of C with the changes in it. In either case, if I decide the changes I made don't work, I want to roll back to the way my data was before. If I delete that snapshot, in either of those diagrams, the green block would be removed. And the old red C block would go back into place. So I've essentially rolled back my data. I don't have multiple full copies of my data. I just keep track of the changes to my data from the point I decide I want a snapshot. So it's not like replication where it could take multiple times the entire size of my data in storage. I'm just storing individual blocks that change. So the additional overhead for snapshots could be very, very low. But it's nice, especially in testing environments. If you're doing software design or something like that, you say, all right, I'm going to run a test. I want to see how it affects my data. You know what? The test failed, not give me the results I expected. So I want to completely roll back the results of that test I just ran. Good thing I ran a snapshot beforehand. I choose to roll back and everything is the same way it was before I did the test and before I made any changes. Finally, I want to mention professional services quickly too. Ingram Micro does offer professional services. We do offer things like deployment servers. Deployment services. So if you need someone to deploy storage systems at branch sites or replication sites, things like that, if it's a facility that you don't have easy access to as a reseller, and you would like somebody to do those services on your behalf, we do have those capabilities. Ingram Micro Professional Services also offers IT staffing services. So if you have a customer who's looking for somebody to provide them with a help desk or perhaps monitor and manage their data center, professional services can put you in place with somebody who can do that as well. That brings us to the end of our presentation. I hope that was useful. If you do have any further questions on storage, please feel free to reach out to Ingram Micro's Solution Design and Services team. Thank you much for your time.